This is actually a very important aspect of climatology. I'm calling it here large-scale wind circulation. Another way you could look at it is global circulation. It's also referred to as the global circulation model. What this is going to show us is it's going to explain why the general climate is the way it is in most locations on the planet. So like I say, it's a very important concept. Now this is an idealized global model without land surfaces, and land surfaces are going to change things a little bit, but this is going to give you a really good idea of what the general circulation is like on planet Earth. All right, let's start right here. There's going to be 4 zones you need to know. We'll start off with this one right here. You see this dashed line with L's. Again, this is our equatorial region. This is the area on the planet that's the hottest. That hot ground, that hot surface, heats the air and causes it to rise. So this belt with all these L's, low pressure. The air is being lifted off it, so it's lower pressure. Whenever you got low pressure at the surface, air wants to flow in to fill that void. Not quite a void, but a semi-void, call it. Look at these arrows. They're showing you that from the northern hemisphere and the southern hemisphere, wind is moving into that area. This is a special area, and this is the first one. I'm going to label it number 1 over here. And the name for that is the Intertropical Convergence Zone. Now, we don't like writing it out. That's a long word, right? So you'll always see it referred to pretty much as the ITCZ. Okay, so the ITCZ then, on planet Earth, is this area of rising air. What happens when we lift air? We cool it, we condense it. This is a ribbon of clouds and rain showers all around almost all around the Earth, okay? Intertropical convergence zones, cloudy, wet, low pressure. All right, if we look over to the side here, you're depicting here rising air off the intertropical convergence zone. Remember, it's hot air, it's rising. So some of that air rises up and then travels at high altitude to about 30 degrees north and south. Now, it's going to vary. So, but now you see it's descending air there. Descending air has the opposite characteristic of rising air. Rising air, ascending air, cools, condenses clouds and rain. Descending air compresses, warms, and dries. So anything around this zone is high pressure, is going to be probably warm and dry. And we have a name for this zone. Okay, the second zone is called subtropical high pressure. And we'll just put an H here. Remember, this was low pressure here, okay? All right, so anyway, totally different from the intertropical convergence zone, clouds and rain. You're going to be warm and dry here in this zone because of the descending air. Now, one of the guys that kind of figured this out, his name was Hadley. And so we've named this thing called the Hadley Cell after him. All the Hadley Cell is illustrating the rising air off the ITCZ, curling up toward the north, and then descending. Now, after it descends, some of that air simply returns back down to the intertropical convergence zone in a cell called the Hadley Cell. However, a lot of that air hits the surface, travels along the surface until it encounters this. What are we looking at up here? So let's go over here and actually go up to the 4th zone. This is polar high pressure. Call it polar H. And what's going on up here? Ground surface is very cold. It's actually mostly frozen ocean up here. This is the Arctic up here. So very cold land is going to make the air very cold above it. Cold air is very dense air. The molecules are close together. Cold, dense air. Here comes warm air approaching it. Now here's another important concept in climatology and meteorology, that air masses of different temperature and moisture content do not mix. They won't mix. Think of oil and water. You pour water onto oil, they don't mix together. A boundary forms. Well, they're illustrating a boundary that forms between the cold, dense air and this warmer air. So, here's the other thing. So as this warm air moves up and comes in contact with the cold air, it's warmer, it's lighter, it's forced to rise up above it. So we see this warm air coming up and rising. Hey, we got lift again. Anytime we get lift, cool, condensing, clouds, and storms. This is a very stormy area, and that's our third zone. It's called subpolar low pressure. Okay. All right, so if you look at this here, 4 zones we need to be aware of. These are the 4 major zones on the planet. Intertropical convergence zone, low pressure at the surface. Clouds, rain, thunderstorms, stormy. You move up, anywhere from, say, 20 to 35 degrees north, around there. Descending air. So we've got warm, dry air in that zone, subtropical high pressure. As that warm air moves up, it encounters the polar front, which is the front is the boundary between the cold air and the warmer air. That air is forced to ascend, cools, condenses, forms storms. Low pressure, cloudy, stormy, snowy, rainy. But then up in here, if we go back to here, this zone up here is high pressure again. Generally where you have high pressure, you've got clear skies. So let's just, to review it. Intertropical convergence zone, low pressure, clouds, rain. Subtropical high pressure, descending air, high pressure, clear, warm, dry. This boundary zone, subpolar low pressure, cloudy, stormy. Finally, polar high pressure, clear, cold. Okay? So just, to reiterate, if you take a look at this, we're going low pressure, high pressure, low pressure, high pressure. We kind of alternate. We alternate this high and low pressure.